Astronomers today estimate that there are more than 2 trillion galaxies in the observable universe, each one a collection of hundreds of billions of stars, dust, gas, and the unseen halo of dark matter that gives it weight. Even as our telescopes expand their reach, the numbers grow. The Hubble Space Telescope once suggested a mere few hundred billion. When the James Webb Space Telescope began sending its images back, that estimate multiplied, revealing galaxies from when the universe was less than 500 million years old. Every new image is a glimpse backward through time. Light travels at a fixed pace, 299,792 kilometers per second, so the farther we look, the older the light. When Webb captures a smudge from the dawn era, we are seeing a structure as it existed over 13 billion years ago, only a few percent into cosmic history. That distant glow is fossil light, photons stretched by the expansion of space until they arrive as whispers in the infrared. Galaxies form from the same simplicity that filled the early universe, mostly hydrogen and helium. Within a few hundred million years after the Big Bang, the first regions of slightly higher density began to collapse under their own gravity, pulling gas inward. Simulations show these protogalactic clouds spinning up as they accreted matter, their motion conserving angular momentum, flattening into disks. Stars ignited in bursts, producing radiation and metals that enriched the gas for future generations. By 1 billion years, the first recognizable galaxies shimmered, compact, clumpy, bright with newborn suns. The modern Milky Way is the result of that long, patient evolution. Its disk stretches roughly 100,000 light-years across. Its stellar halo may reach 10 times farther. At its heart lies Sagittarius A*, a black hole about 4.3 million solar masses. Around it, stars whip through space at thousands of kilometers per second, tracing orbits that reveal the hidden mass. The Sun, one ordinary star among billions, circles the galactic center every 230 million years, gliding through the Orion arm of a vast spiral. Galaxies like ours are typical members of a population astronomers classify by shape: spiral, elliptical, lenticular, irregular. Spirals, rich in gas and dust, are active star-forming systems. Ellipticals are older, smoother, often the result of mergers that exhausted their fuel. Irregulars are galaxies still in turmoil, distorted by gravity or collision. Yet all share a similar story: the balance between gravity pulling inward and energy pushing outward. When galaxies collide, and they often do, the result is not the chaotic destruction one might imagine. Stars themselves almost never strike each other, separated by light years of emptiness. Instead, their mutual gravity stirs waves of gas that compress and ignite, birthing new stars in brilliant sweeps. Over millions of years, orbits settle, shapes merge, and a new galaxy emerges. Older, larger, transformed. The Milky Way itself is midway through such a process. In roughly 4.5 billion years, it will merge with the Andromeda galaxy, creating a single elliptical structure some call Milkomeda. Observations across the electromagnetic spectrum show how these interactions drive evolution. Radio telescopes map the cold hydrogen that outlines galactic disks. Infrared observatories trace warm dust where stars are forming. X-ray instruments reveal hot gas and the fierce emissions of black holes. Each wavelength adds a note to the composition, allowing astronomers to reconstruct the symphony of cosmic growth. The grandest scale of structure, the cosmic web, is woven from galaxies linked by filaments of dark matter and gas. Clusters form where filaments intersect, bound by gravity into colossal systems tens of millions of light-years across. Between them lie vast voids, regions nearly empty, spanning up to hundreds of millions of light-years. Computer simulations like the Illustris TNG and Eagle projects reproduce these patterns, showing how gravity sculpts the same intricate lacework that deep sky surveys observe. When cosmologists measure that structure, They test the fundamental parameters of the universe itself. The average density of matter, the rate of expansion, the fraction of dark energy, all can be inferred from the spacing and motion of galaxies. According to the Planck mission and subsequent analyses, ordinary matter accounts for only 4.9% of the total energy density. Dark matter contributes 26%. Dark energy fills the remaining 69%. Galaxies, luminous though they are, trace only the tiny visible portion of an invisible whole. Still, they are the traces we can see, the lanterns marking the contours of the cosmic landscape. By mapping their distribution, we reveal the geometry of space itself. From the earliest proto-galaxies to the giant ellipticals of today, their history mirrors the universe's own timeline. The star formation rate peaked about 10 billion years ago and has declined since, a gradual quieting sometimes called cosmic noon giving way to cosmic dusk. In the far future, as fuel runs low, galaxies will dim, leaving behind long-lived red dwarfs and the slow embers of remnants. Yet even in that distant prospect, there is balance. The same physics that will end star formation also ensures the stability of existing structures. Dark matter halos will continue to bind their stars for trillions of years. Orbiting within them, remnants of supernovae, neutron stars and black holes, will persist as the enduring skeletons of what once burned bright. To study galaxies is to measure both motion and stillness. Spectroscopy reveals their velocities through redshift, the stretching of light as the universe expands. Nearby systems like Andromeda show blue shift, moving toward us, most others recede. The farther a galaxy lies, the faster it appears to move away, following Hubble's law with a constant now measured at roughly 70 km per second per megaparsec, though precision studies refine that number. The expansion is not motion through space, but of space itself, the very fabric stretching between every point. Modern surveys such as the Sloan Digital Sky Survey and Dark Energy Spectroscopic Instrument Project have charted millions of galaxies, building three-dimensional maps that resemble coral reefs of light. Each dot represents not just a single system but the combined glow of billions of stars, each star surrounded by planets, many of which may harbor their own skies and seasons. It is a humbling vista. The universe is both infinite and finite, structured yet open. And through all this data runs a thread of elegance. The mathematics that describes how gravity binds, how angular momentum stabilizes, how radiation cools. In those equations lies not cold precision, but harmony, a pattern that repeats from the smallest atom to the largest cluster. Galaxies are the universe's way of organizing matter into meaning, of turning randomness into form. They are both the byproduct and the artist of time. Even now, instruments like Webb and the Atacama Large Millimeter Array continue to look deeper, revealing smaller, dimmer galaxies that push the known edge of formation ever closer to the beginning. Some of these first light objects are barely a few hundred million years younger than the Big Bang itself, their starlight stretched into the infrared by 13.4 billion years of expansion. Each detection refines our models. How quickly did gas cool? How did ionization proceed? What role did black holes play in early growth? As the data accumulate, the story gains clarity, yet mystery remains. Galaxies appear mature earlier than theory predicts, implying that structure formed faster or more efficiently than expected. Perhaps the feedback from early black holes was different. Perhaps dark matter behaves in subtler ways. The cosmos invites curiosity even in its quietest corners. Here, amid numbers and distances, there is serenity. To measure the universe is to listen to its slow breathing, the expansion, the clustering, the fading of light over epochs longer than imagination. Each calculation becomes an act of contemplation. And as telescopes gather their faint photons, the mind gathers a sense of scale so vast it dissolves anxiety. Galaxies are not distant. They are continuous with the atoms in our bodies, part of the same unfolding equation. Now, Let the mind drift outward again, beyond the Milky Way, to the thin edges where its stars thin into halo and then into intergalactic night. Beyond lies the faint scattering of other systems, each glowing quietly. They hang in the dark like lanterns suspended in a gentle current. From here, science and wonder are no longer separate things. They are the same perception viewed from different sides. Out here, at the scale where clusters of galaxies thread together like filaments of light, the laws of physics seem patient and absolute. On average, galaxies are separated by a few million light-years, yet gravity links them into superclusters that drift slowly apart as cosmic expansion carries all things outward. The largest known gravitationally bound structures, such as the Laniakea supercluster, which includes the Milky Way and Andromeda, span more than 500 million light-years from end to end. Beyond its boundaries, expansion wins completely. Space stretches faster than gravity can hold. Within these superclusters, dark matter provides the invisible scaffolding. It cannot be seen, but it announces its presence through motion. Galaxies rotate faster than visible mass allows. Gravitational lenses bend light more strongly than starlight alone predicts. The evidence is everywhere, in rotation curves, in cosmic microwave background fluctuations, in the slow growth of structure mapped across billions of years. Whatever dark matter is, a yet undetected particle, a new symmetry of physics, it outweighs ordinary atoms 5 to 1. Dark energy, stranger still, fills the spaces between. Observations of distant supernovae show that expansion is accelerating, driven by a repulsive component that acts on the largest scales. Its nature remains the greatest mystery in cosmology. Yet its presence shapes the destiny of galaxies. Clusters will drift apart, and isolated islands of stars will fade beyond each other's horizons. In time, only local groups will remain bound, floating in an ever darker sea. Astronomers look for signatures of this evolution in the faintest details of light. Spectra from quasars, the blazing hearts of galaxies whose central black holes devour matter, carry the fingerprints of intergalactic gas clouds along the way. Each absorption line tells of temperature, composition, and motion, building a layered map of the medium that links galaxies across time. Inside galaxies, the processes continue on smaller scales. Star formation consumes molecular clouds at rates measured in solar masses per year. In the Milky Way, that rate is about 1.5 to 2 solar masses per year. In starburst galaxies, it can be hundreds. Magnetic fields thread these clouds, guiding collapse and channeling outflows. Supernova shocks enrich the surrounding gas, stirring turbulence that seeds the next generation. The cycle is self-regulating. Feedback prevents runaway collapse, ensuring a steady rhythm instead of a flash and silence. In galactic centers, supermassive black holes provide another form of feedback. When accretion rates rise, jets and radiation pour outward, heating surrounding gas and halting further infall. This cosmic thermostat maintains a balance between creation and quiescence. Observations with the Event Horizon Telescope have even resolved the shadow of a black hole, a ring of radio light around darkness, confirming general relativity's predictions at the brink of the unknown. Across wavelengths, galaxies tell complementary stories. Ultraviolet reveals newborn stars. Visible light traces mature populations. Infrared peers through dust to hidden nurseries. Radio maps the cold hydrogen that fuels everything. X-rays uncover the violent interplay of hot gas and compact objects. Together these bands compose a spectrum not just of energy but of time, each frequency a different chapter in a galaxy's life. When astronomers stitch these observations together, they find unity. Whether near or distant, massive or small, every galaxy follows the same physical grammar. The equations of gravity, fluid dynamics, and thermodynamics shape them all, varying only in initial conditions. The universe appears random in detail but consistent in rule. This consistency allows prediction, Yet it also inspires humility. The cosmos owes its beauty not to chance but to the quiet coherence of law. Today's instruments extend perception almost to the beginning. The James Webb Space Telescope routinely detects galaxies with redshifts above 13, meaning their light left when the universe was only 320 million years old. Some are surprisingly massive, challenging models of early star formation. Others show signatures of heavy elements earlier than expected, suggesting that the first generations of stars lived fast and died explosively, enriching their surroundings within a few tens of millions of years. Future missions, the Nancy Grace Roman Space Telescope, the Square Kilometre Array, the Vera Rubin Observatory, promise even deeper clarity. Roman will map the infrared sky to measure dark energy's effect on structure. The Rubin telescope will survey the visible sky every few nights, capturing the slow dance of variable stars and transient events across billions of galaxies. The Square Kilometre Array will listen in radio to the neutral hydrogen that bridges cosmic epochs, tracing the universe's evolution from darkness to light. Each observation refines parameters of the standard cosmological model, the so-called lambda cold dark matter framework, yet each discovery reminds us how provisional our understanding remains. Why is the cosmological constant so small yet non-zero? What is the true nature of dark matter particles? How did the first black holes grow so quickly? Science advances by asking more precise versions of these same questions. Behind the technical detail lies a subtler revelation. Galaxies are archives of time. Their stars record the chemical evolution of the universe. Their motions preserve its gravitational history. When we observe them, we reconstruct billions of years from the faintest light. It is forensic cosmology, patient and exacting, yet also profoundly human, an act of curiosity extending beyond survival, beyond need. Consider again the Milky Way. It resides within the Local Group, a cluster of more than 60 known galaxies, including Andromeda, Triangulum, and many dwarfs. All orbit a common center of mass, moving through a halo of dark matter roughly 10 to the power of 12 solar masses strong. Beyond the Local Group lies the Virgo cluster, and beyond that, the tapestry of superclusters threading outward toward the cosmic microwave background. Each layer echoes a deeper scale, from star to cluster to web. The numbers are staggering, but their immensity invites calm rather than fear. When measured against cosmic time, even great events unfold slowly. A spiral arm completes one rotation in hundreds of millions of years. A cluster evolves over billions. The sky above us tonight is a frame in an eternal film whose motion is too slow to see, yet certain. Through decades of observation, the human view has widened from a single galaxy to a cosmic census. Instruments on Earth and in orbit have shown that galaxies are not scattered randomly but arranged in filaments and walls, forming a structure often compared to foam or coral. Within the voids between these filaments, density is near zero, a silence so complete that light itself passes unscattered. Such patterns confirm the predictions of quantum fluctuations stretched by cosmic inflation, connecting the tiniest scales to the grandest. Thus, every point of light in the night sky, every faint smear in a deep field image, is evidence of coherence across all of existence. The same forces shaping the spin of electrons determine the spin of galaxies. The symmetry is profound, and in that symmetry there is peace. When scientists speak of the fate of galaxies, they describe long, graceful transitions. The gradual dimming as star formation ceases, the settling into elliptical forms, the slow dispersal of clusters as dark energy dominates. On timescales of trillions of years, starlight will fade, the universe will become cold and dark. Yet even then, physics continues. Protons decay, black holes evaporate, particles tunnel into radiation, a steady whisper of change carrying forward forever. To contemplate these processes is to approach stillness. The equations do not rush, they unfold in patience measured by eternity. Every constant, every coefficient, feels tuned not by intention but by the quiet necessity of consistency. Download 9. Here the universe does what it must, and in doing so, becomes beautiful. At this boundary between understanding and awe, the mind begins to slow. The catalogue of data, distances, luminosities, redshifts, becomes more than information. It becomes rhythm. Expansion is breath. Structure formation is heartbeat. The cosmos is alive not in the biological sense but in the mathematical one, a continuous transformation governed by elegance. Let that awareness settle. Galaxies are not remote lanterns but reflections of a single unfolding pattern that includes us. The same physical laws that sculpted them govern the atoms of our blood, the synapses that let us wander. Through science, we glimpse this continuity. Through reflection, we feel it. And in that feeling, a bridge forms, the beginning of transition. Soon the language of measurement will soften into the language of quiet marvel. The voice of the narrator will slow, the data will fade into imagery, and thought will become dream. For now, rest in the knowledge that the universe is vast, ordered, and serene, that galaxies spin not in haste but in harmony, and that to observe them is to share, however briefly, in their peace. Far beyond the faint borders of our own supercluster, the universe extends into a filamentary lattice of light. Galaxies cluster along invisible threads of dark matter, drawn together by gravity and separated by deep, yawning voids. The structure of it all has been mapped in exquisite detail. Billions of light years of cosmic geography, where each bright node represents countless suns, and each strand traces the gravity that sculpted them soon after the beginning of time. When astronomers look across these immense distances, they're peering backward in time. The light reaching us now began its journey billions of years ago, when the universe was young, dense, and hot. Some of the most sensitive instruments ever built have captured this faint light, revealing galaxies as they appeared only a few 100 million years after the first atoms formed. They are small, irregular, and bursting with new stars, glowing in ultraviolet light that has since been stretched to the deep red by the universe's expansion. In those early epochs, star formation was intense. Clouds of hydrogen collapsed under their own gravity, igniting into massive, short-lived stars that quickly enriched their surroundings with heavier elements. The first galaxies grew by merging, forming larger spirals and ellipticals. This process continues even now. When two galaxies meet, they don't collide like solid objects. They pass through one another, their stars rarely touching. Yet their mutual gravity pulls and warps them, triggering waves of starbirth that light up their arms like cosmic fireworks. The universe is still alive with these encounters. In the local group, the small cluster that contains our Milky Way, our nearest large neighbor, Andromeda, is approaching at nearly 100 kilometers per second. In about 4 billion years, the two will merge, their stars dancing through tidal currents of gas and dust, settling at last into a single, larger galaxy. The night sky of that distant future will shimmer with countless suns drawn into new patterns, while our descendants, if any remain, will look up and see not one spiral but a vast, elliptical glow filling the heavens. Every galaxy tells a story written in starlight. Some spin serenely, their arms stretched out like the petals of a flower. Others are chaotic, distorted by gravitational encounters or the outflow of material from their central black holes. These supermassive black holes, with masses millions or even billions of times that of our Sun, lie at the heart of nearly every large galaxy. When matter falls toward them, it releases immense energy, often outshining the rest of the galaxy combined. The radiation from these central regions can sculpt the surrounding gas, regulating star formation and shaping the evolution of the whole system. Recent observations show that these black holes and their host galaxies grow together. As galaxies merge, their central black holes spiral inward, eventually coalescing in a burst of gravitational waves. Across cosmic time, This process helps build the large, mature galaxies we see today. The faint ripples in space-time from these ancient mergers still travel through the universe, passing silently through everything, reminders of a violent but beautiful history. The diversity of galaxies is extraordinary. There are grand design spirals, neatly ordered, barred spirals with central bridges of stars, lenticulars that lie between spirals and ellipticals, dwarf irregulars that flicker faintly on the edges of clusters, and giant ellipticals containing trillions of stars, the relics of countless mergers. Each is a laboratory of physics, chemistry, and time, holding clues to how the universe built complexity from simple beginnings. Within them, stars are born in dense molecular clouds, cold regions where hydrogen molecules cling together and dust absorbs the faint glow of nearby light. Inside these clouds, gravity takes hold. Clumps collapse, heat builds, and nuclear fusion begins. The star ignites, sending winds and radiation into its surroundings, dispersing the cloud and triggering further collapse in nearby regions. This cycle, ongoing for billions of years, is the heartbeat of a galaxy. And yet, the more astronomers observe, the more they find galaxies that challenge expectations. Some massive systems appear surprisingly young, with fresh bursts of star formation, while others, long thought to be quiescent, show faint signs of new life. It seems that galaxies can rejuvenate themselves, pulling in streams of cold gas from intergalactic space or awakening dormant black holes that stir their cores. The universe, though ancient, is not static. It evolves quietly, continuously, like a slow-turning tide. Measurements of distant galaxies reveal that cosmic expansion is accelerating. Space itself grows at an increasing rate, stretching the light from faraway systems until they fade beyond detection. The faintest galaxies now visible mark the limits of the observable universe, about 46 billion light-years in every direction. Beyond that, their light has not yet reached us, and perhaps never will. The cosmos may extend infinitely, or it may fold back on itself in dimensions we cannot perceive. For now, all we can see are the islands of matter glowing within the dark. In recent years, deep infrared surveys have uncovered galaxies that existed just a few 100 million years after the Big Bang. Their presence hints that structure formed faster than once believed. Dust and heavy elements appear earlier, suggesting that the first generations of stars lived brief, brilliant lives, enriching the cosmos with the ingredients for future worlds. The light from those systems, stretched and dimmed by cosmic expansion, carries the fingerprint of hydrogen's earliest transitions. By studying it, astronomers can trace how matter cooled, condensed, and became luminous. Closer to home, large surveys have catalogued billions of galaxies, mapping their distribution across cosmic web structures. Patterns emerge: long filaments, vast clusters, enormous voids. These observations agree remarkably well with simulations of cosmic evolution based on the laws of gravity and the mysterious presence of dark matter and dark energy. The balance between them, one pulling, one pushing, has shaped everything from the smallest galaxies to the grandest superclusters. As instruments continue to improve, they reveal galaxies in greater detail. We see individual star-forming regions, faint halos of hot gas, and delicate tidal streams stretching between companions. Some galaxies emit radio waves from electrons spiraling around magnetic fields. Others glow in X-rays from the gas heated near black holes. Together, these wavelengths tell a complete story, a multi-layered portrait of energy and matter intertwined. Even the quietest galaxies hum with subtle motion. Stars orbit in complex patterns, their paths governed by both visible and unseen mass. The rotation curves of spirals remain flat far from their centers, betraying the influence of something more than starlight, an invisible halo that outweighs all the luminous matter combined. The composition of this dark matter remains unknown, but its gravitational fingerprints are unmistakable. Without it, galaxies would fly apart. With it, they hold together in elegant balance. In the outskirts of clusters, galaxies drift like leaves on a cosmic pond. Some fall inward, drawn by gravity, others are flung outward through gravitational interactions. Their paths trace the ebb and flow of mass across billions of years. The faint intracluster light, starlight stripped from galaxies during these encounters, glows like mist between them, a diffuse reminder of all that has been lost and merged. At the heart of the largest clusters, enormous ellipticals dominate, surrounded by swarms of smaller companions. They sit within vast halos of dark matter and hot gas, each cluster a gravitational metropolis in the grand architecture of the universe. These are the places where galaxies live and die, where collisions are frequent and evolution accelerated. The interplay of forces here mirrors, on an enormous scale, the processes that once shaped our own home galaxy. Even now, new galaxies are being born in the quiet regions of space, fed by streams of cool hydrogen that flow along cosmic filaments. Their faint glow is a whisper from the edge of time, a reminder that creation never truly ends, it only changes form. As we look deeper and understand more, the vastness becomes less overwhelming and more intimate. Every observation, every photon collected from a distant system, connects us to a story written across billions of years. The same physical laws that guide the motion of galaxies also govern the atoms in our bodies. The carbon, oxygen, and iron that make us were forged in ancient stars, scattered through the galaxy, and drawn together again to form new systems, new worlds, and eventually, life capable of looking back at its own origins. The thought of it slows the mind. Galaxies are not separate from us, they are extensions of the same cosmic fabric. The light that left a distant spiral billions of years ago now touches our retinas, completing a journey almost beyond imagination. In that moment of contact, between ancient light and living consciousness, the universe becomes aware of itself. The light that reaches us is old beyond reckoning. Each photon that touches our world began its journey when continents were still forming, when our species did not yet exist, when the Milky Way itself was still gathering its arms. To watch a distant galaxy is to look across a gulf of both space and history, to see what was, not what is. Yet somehow, in that ancient glow, there is also the quiet promise of continuity, the same laws of physics playing out in places we will never reach. As the instruments of observation have improved, astronomers have begun to see subtle structures in that glow, faint arcs of gravitational lensing that reveal the invisible mass between us and the light source. These distortions are not flaws, they are cosmic fingerprints, showing where dark matter bends the geometry of space itself. By tracing those distortions, scientists reconstruct the hidden scaffolding that holds galaxies in place. The result is a cosmic topography, a map of what cannot be seen directly, drawn by light that has traveled for eons. Every measurement adds to a picture of delicate balance. The expansion of the universe stretches the distances between galaxies, yet their local clusters remain bound by gravity. On the largest scales, matter and energy contend in quiet opposition. Gravity striving to pull everything together, dark energy urging everything apart. Their interplay sets the rhythm of cosmic history. If dark energy continues its current behavior, distant galaxies will someday recede beyond the limit of observability, their light red shifted into invisibility. The night sky, far in the future, may appear empty once more, leaving only the nearest stars to whisper of what once was. Even that outcome holds a kind of peace. The universe has always been transient, each structure a brief condensation of order in an ocean of entropy. The galaxies we admire today are still evolving. Gas becomes stars. Stars shed their matter. The matter becomes new gas. Black holes merge. Galaxies grow. Collisions reshape the sky. Nothing is static, and yet the patterns persist. Spirals, ellipses, the faint arcs of colliding clusters, repeating the same harmonies in different keys. The deep surveys have revealed something unexpected. The first galaxies formed earlier and faster than models once suggested. Within the first few 100 million years, matter had already condensed into luminous structures, their spectra showing heavy elements that required several generations of stellar life and death. It means that the early universe was efficient, creative, alive with transformation. What we once thought of as a long cosmic dawn may have been a burst of rapid brilliance, stars and galaxies blooming in a rush before the universe settled into a slower rhythm. In those ancient systems, the ratio of gas to stars was immense. Star formation rates were hundreds of times higher than in the Milky Way today. Yet even now, in our quiet corner of space, the same fundamental physics operates. Clouds of gas collapse, stars ignite, planets form. Across time and distance, the universe recycles itself. Matter that was once in the heart of a giant star may now drift as interstellar dust, waiting to be drawn into another generation of creation. The newest observations in the infrared show intricate details of these star-forming nurseries. Filaments of gas threaded by magnetic fields, tiny knots that hide protostars, delicate outflows carving cavities in the surrounding medium. Each point of light on those images represents a real place, often thousands of light years wide, where gravity and radiation dance in perfect counterpoint. The chemistry that unfolds there will someday determine whether new worlds can form, whether oceans can exist, whether life might emerge under some distant sun. The further we look, the more we realize that galaxies are ecosystems. They are not mere collections of stars. They are self-regulating systems where feedback loops govern growth and decay. The radiation from young stars shapes the gas around them. Supernovae seed new elements and drive winds that clear regions of space. Black holes at the centers release jets that heat surrounding material, preventing runaway star formation. Each of these processes operates across incomprehensible scales, yet together they maintain equilibrium, allowing the galaxy to endure for billions of years. In the cool silence of intergalactic space, isolated galaxies drift alone, cut off from the inflow of fresh gas. Without that supply, their star formation dwindles, and they slowly fade, becoming red and quiescent. Astronomers call them red and dead, but the phrase conceals the quiet dignity of their state. They are ancient libraries of starlight, archives of everything that has happened since the dawn of time. Their stars still shine, each one a record of the universe's earlier epochs, glowing gently into the dark. The study of galaxies has also revealed our own place among them. The Milky Way, with its 100 billion stars, is just one member of a small local group, itself part of a larger structure, the Virgo supercluster, which in turn lies within an even grander feature known as the Laniakea supercluster. Within that expanse, streams of galaxies flow toward common gravitational centers, forming what looks, in simulation, like a vast river system of light. The scale is so immense that even light takes hundreds of millions of years to cross from one end to the other. Yet every part of that web is connected. Looking at such immensity can feel overwhelming, but there is comfort in it too. The forces that shape galaxies are the same that shape the atoms in your blood, the same curvature of space-time that holds you to Earth. The difference is only one of scale. You are, in a very literal sense, part of the same cosmic story, a fragment of matter that has briefly achieved awareness before returning to the flow. This realization is what scientists often describe, quietly, as cosmic perspective. It is not an abandonment of detail or discipline, but a broadening of understanding. To study galaxies is to study the conditions that allow existence itself, the way gravity sculpts form from chaos, how complexity arises from simplicity, and how even in vast emptiness, structure can emerge. The universe is not random, it is patterned, elegant, and astonishingly consistent. And yet, within that consistency, there is room for wonder. Observations have shown faint glows in the outskirts of galaxies, diffuse halos of stars that extend far beyond visible limits. These halos may be the remains of ancient mergers, tidal debris from long-lost companions. They remind us that the edges of galaxies are not boundaries but thresholds. Beyond them, space continues, and even there, matter leaves its trace. As we watch, the instruments on Earth and in orbit continue to gather light from the distant past. Each photon collected adds another brushstroke to our portrait of the cosmos. The data are analyzed, cross-checked, transformed into color images that reveal what our eyes alone could never see. For those who study them, these images are not just records of distant objects, they are glimpses of time itself, preserved in light. The farther back we look, the closer we come to the beginning. Eventually, we reach a limit, a faint glow that fills all of space, the afterglow of creation. Beyond that, galaxies vanish into darkness. But that darkness is not empty, it is simply beyond our reach. What lies there remains unknown, perhaps unknowable. And yet, in that unknowing, there is a kind of peace, an invitation to imagine, to wonder, to dream. Slowly, as the narrator's voice softens, the story begins to shift. The precise measurements, the catalogued distances, the spectral lines, they fade like stars at dawn, leaving behind the feeling they evoke: immensity, continuity, calm. The mind relaxes into the rhythm of expansion, of drifting galaxies, of unhurried time. All the structures that have filled the cosmos with light continue their silent rotation. The spirals turn, the clusters glide, the voids remain still. From here, at this scale, the universe feels less like an equation and more like a breathing presence. Each galaxy becomes a note in a vast, ongoing harmony, each orbit part of a slow cosmic song. And as the last of the scientific details dissolve into that quiet, the listener feels the pull toward rest, toward the tranquil realization that to understand the universe is not to dominate it, but to dwell within it, peacefully, in awe. In the quiet darkness of the early universe, there was no light. Only a sea of potential, a soft hum of energy, spreading outward, cooling, stretching through the vastness of time and space. The universe had only just been born, and already it was dreaming of structure. As the cosmic fireball of the Big Bang began to fade, matter drifted into being. Tiny fluctuations, smaller than the breath of an atom, rippled across the newborn cosmos. These fluctuations were the seeds of everything, of stars, of galaxies, of the cosmic web that would one day hold 1 trillion suns. At first, there was only hydrogen and helium, the simplest elements, light and pure. Gravity, the universe's sculptor, began to work with these simple tools, pulling the gas together. It gathered in invisible hands, forming clouds, filaments, and knots across vast distances. Download here, these were the first hints of galaxies to come, faint and unformed, but destined to shine. Over millions of years, those clouds thickened. As they collapsed, their centers grew hot and dense. And in those cores, the first stars ignited. These were ancient, massive stars, short-lived beacons that blazed fiercely before collapsing in titanic supernovae. Their explosions scattered heavier elements into the darkness: carbon, oxygen, iron, the building blocks of future worlds. The galaxies were not yet elegant spirals or majestic ellipticals. They were clumps, irregular and wild, colliding and merging constantly. Each collision reshaped the growing universe, like waves forming patterns in the sea. Over time, the cosmic web emerged, an intricate lattice of dark matter and gas, stretching across billions of light years. Along its filaments, galaxies gathered like dewdrops on a spider's thread. They became the glowing nodes of a vast, interconnected structure, the architecture of the universe itself. These early galaxies were small, faint, and chaotic, but they evolved. Some merged into larger systems, forming the ancestors of the Milky Way. Others remained isolated, quietly spinning in the emptiness. Gravity continued its patient work, shaping and reshaping the grand design. The young universe was still restless. Its galaxies glowed with blue light, the mark of hot, newborn stars. They burned quickly, feeding on their reservoirs of gas. But as their stars lived and died, as their supernovae stirred and enriched the interstellar medium, the galaxies began to mature. The balance of creation and destruction gave rise to complexity. Gas cooled and condensed into new generations of stars. Dust formed from the ashes of supernovae, drifting through the galactic arms. Planetary systems began to appear, orbiting distant suns. And with them, the story of matter grew more intricate. If one could drift silently through the cosmos at that time, it would feel like floating through a luminous ocean. Everywhere, faint smudges of light, protogalaxies, shimmered in the distance. Some were bright blue spheres. Others stretched and twisted, shaped by the invisible hand of dark matter. Between them, vast voids of emptiness stretched for millions of light years, silent and still. Everywhere, the faint glow of the cosmic microwave background still lingered, the fading afterlight of the Big Bang, like an ancient whisper echoing through eternity. The first galaxies formed roughly 400 million years after the beginning of time. Astronomers call this period the Cosmic Dawn. It was the era when the universe transitioned from darkness to light, when stars and galaxies illuminated the intergalactic medium. From that point onward, light began to fill the cosmos. Galaxies multiplied, evolving in form and scale. Small dwarf galaxies merged into grand spirals, starbursts ignited in massive collisions. Over billions of years, galaxies became the fundamental units of cosmic organization. Islands of light in a sea of darkness. Each galaxy contained hundreds of billions of stars. Each star might host planets, moons, and rings. Some worlds were frozen, others burned. A few may have harbored oceans, clouds, and perhaps, in rare and precious cases, life. In this way, galaxies became more than just structures of matter. They became the homes of possibility. The Milky Way, our home galaxy, was born from a lineage of such mergers and transformations. Long before our Sun existed, the Milky Way was assembling itself, collecting smaller galaxies, absorbing their stars, weaving them into its spiral arms. Our galaxy, like countless others, is a living record of cosmic evolution. Its stars tell the story of time, the oldest in its halo, the youngest along its arms, where gas still cools and collapses to form new suns. Its spiral shape is not static. It slowly rotates, billions of stars dancing in vast, slow motion, taking hundreds of millions of years to complete a single turn. If one could step outside and look upon the Milky Way from afar, it would appear as a glowing disk, its light concentrated in a golden center. Around it, spiral arms curl outward, dotted with blue star clusters and dark lanes of dust. Surrounding all of it is a faint halo, a ghostly sphere of ancient stars and dark matter, stretching far beyond the visible edge. Every galaxy, no matter its shape or size, is bound together by gravity. Yet at the same time, galaxies themselves are moving apart, carried by the expansion of the universe. The space between them grows with every passing moment. Over cosmic time, they drift farther and farther away, their light stretching into redder wavelengths, the signature of an ever-expanding cosmos. As galaxies move through space, they continue to collide and merge. These encounters can last hundreds of millions of years. When two galaxies meet, their stars rarely collide directly. The distances between them are vast, but their gravity interacts. It pulls and distorts, creating tidal tails, rings, and streams of stars that arc gracefully through the void. Such mergers trigger intense bursts of star formation, as clouds of gas are compressed and ignited. The result is a brilliant but brief flare of galactic life, before the two systems settle into a new, merged form. Over billions of years, this process builds larger and more massive galaxies. Elliptical galaxies, for instance, often form through these mergers. Vast, smooth systems filled with old, red stars and little gas. Spirals, in contrast, retain their structure when left relatively undisturbed. The universe's grand design unfolds through this endless interplay of order and chaos. And in the stillness of space, there is a rhythm to it all. The slow breathing of galaxies, the rise and fall of light across billions of years. When we observe the distant cosmos, we are looking back in time. The light from the most distant galaxies we see today began its journey billions of years ago. It has crossed the expanding universe, stretching and fading, carrying with it a silent story of how everything came to be. Every point of light in the night sky, every soft shimmer of a distant nebula, is part of this story. It is the history of the cosmos written in starlight. And as we drift through that light, aboard a small planet circling an ordinary star, within an ordinary spiral galaxy, we find ourselves part of it too. We are, in every sense, made of galaxies. The atoms in our bodies were forged in ancient stars, born in early galaxies, scattered by supernovae, recycled into new suns and worlds. We are a continuation of the universe's first acts of creation. To look up at the Milky Way on a clear night is to look into our own origin story. The faint glow across the sky, the river of light, is the combined radiance of billions of distant suns. Each one a whisper from the past, each one a reminder that we belong to something vast, ancient, and ongoing. The galaxies are not just places in space. They are the memory of time itself. When you close your eyes and imagine the universe, perhaps you see stars, countless points of light scattered across a dark sky. But if you could step farther away, if you could lift yourself beyond the scale of stars and see the cosmos in its grand design, you would find that those stars are not alone. They gather, they swirl, they organize themselves into galaxies. Vast, self-contained systems that hold together through the quiet, persistent pull of gravity. Each galaxy is a world unto itself, containing hundreds of billions of stars, immense clouds of gas and dust, and mysterious halos of dark matter that stretch beyond their visible edges. Yet despite this immensity, each galaxy moves as though it were alive, rotating, drifting, evolving through time. Astronomers, in their patient observations, have classified galaxies into many forms. Some are grand spirals, elegant, symmetrical, filled with bright lanes of stars that curl around glowing centers. Others are featureless ellipses, immense ovals of soft golden light. And then there are the irregulars, chaotic, asymmetrical shapes, where gravity and motion have sculpted something untamed. In this endless diversity lies the quiet artistry of the cosmos. The spiral galaxy is perhaps the most iconic. Imagine a glowing disk, tens of thousands of light years across, rotating in serene motion. At its center, a bright bulge of ancient stars glows with a soft yellow light, the heart of the galaxy. From that core, spiral arms extend outward like vast, curving rivers of stars, gas, and dust. Within those arms, young blue stars are born, their light shining brilliantly against the darker backdrop of interstellar space. The Milky Way, our home, is one such spiral galaxy, specifically, a barred spiral. That means a long, straight bar of stars crosses its central bulge, from which the spiral arms extend outward. This bar acts like a gravitational engine, channeling gas inward toward the core, fueling new bursts of star formation and feeding the supermassive black hole that lies at the galaxy's center. If one could travel through the Milky Way, it would take tens of thousands of years to cross even a small fraction of its span, moving at the speed of light. From within, we see only a thin, luminous band stretching across the night, the combined glow of billions of stars seen edge on. But from afar, our galaxy would resemble a graceful pinwheel, its spiral arms winding gently through the darkness. Spiral galaxies are not all alike. Some, like the grand design spirals, have clearly defined arms. Perfect, well-formed curves that sweep gracefully from their centers. Others are flocculent spirals, more patchy and fragmented, their arms broken into clumps of stars and gas. Some are tightly wound, while others stretch loosely into space. Each spiral's shape reflects its history, the balance between rotation, density waves, and gravitational encounters over billions of years. Elliptical galaxies, by contrast, are smoother, rounder, and often older. They lack the structure of arms or dust lanes, appearing instead as soft, glowing ovals suspended in the dark. Within them, stars move in random orbits, not the organized rotation seen in spirals. Most of these stars are old, red, and long-lived, remnants from an earlier era of the galaxy's life. Ellipticals can range from small, dwarf systems to enormous giants containing trillions of stars. Some, like the massive elliptical galaxy M87, are so large that their central black holes weigh billions of times the mass of the Sun. These giants often dominate the centers of galaxy clusters, surrounded by countless smaller companions drawn into their gravitational grasp. Between spirals and ellipticals lies a transitional class, the lenticular galaxies. They resemble spirals flattened into disks, but without the active, star-forming arms. The gas has been depleted, leaving behind a smooth, aged population of stars. Lenticulars tell a story of transformation, perhaps once spiral galaxies that, through interactions and the loss of gas, have grown old and quiet. And then, there are the irregulars, galaxies that defy simple description. They appear warped, stretched, or scattered, their shapes the result of collisions, gravitational tides, or turbulent star formation. Irregular galaxies are often rich in gas and dust, teeming with young, bright stars. They may be small, dwarf irregulars, or large, chaotic systems in the midst of merging with others. The Magellanic Clouds, two small companions to the Milky Way, are such irregular galaxies, orbiting us like luminous satellites in the night. Each of these galactic forms is more than a shape. It is a reflection of a long and complex life, of mergers, collisions, internal dynamics, and cosmic environment. The structure of a galaxy is shaped by the invisible. Beneath the visible light, beneath the clouds of gas and the clusters of stars, lies a vast halo of dark matter. This unseen component outweighs the luminous matter by far. It forms a kind of cosmic skeleton, defining the shape and motion of the galaxy itself. Without dark matter, the stars would not hold together. The galaxy would simply fly apart. It is gravity from this hidden mass that binds everything in a silent, unyielding embrace. When astronomers measure how fast stars orbit the centers of galaxies, they find something curious. According to Newtonian physics, stars farther from the center should move more slowly, yet they don't. The outer stars move just as fast as the inner ones. This flat rotation curve reveals the presence of something unseen, an invisible halo that extends far beyond the visible edge. Dark matter reveals itself not through light, but through gravity. Every galaxy, no matter its shape, has this unseen structure, vast, spherical, extending beyond the reach of the eye. It holds the galaxy together, and perhaps connects it, faintly, to others through the cosmic web. Within each galaxy lies motion on many scales. Stars orbit within the galactic plane. Gas clouds spiral inward, collapsing to form new stars. Entire star clusters move like swarms, bound by shared gravity. These orbits are measured in millions of years, a cosmic clockwork that ticks in slow motion. At the heart of most galaxies lies another mystery, a supermassive black hole. These immense objects, millions or billions of times the mass of the Sun, anchor the centers of galaxies. They are dark, yet their influence is visible in the motion of surrounding stars and gas. When active, these black holes can power quasars, luminous beacons so bright that they can outshine their entire host galaxy. It is a paradox, the darkest regions of the universe producing the most brilliant light. When matter falls into the accretion disk of a supermassive black hole, it heats to extreme temperatures, emitting radiation across the spectrum. Quasars, blazes, and active galactic nuclei are all expressions of this process, the energetic hearts of galaxies in their youth. Over time, as galaxies evolve, their central black holes may quiet. The gas supply dwindles, star formation slows, and the galaxy settles into a calmer phase. Yet the black hole remains, massive and silent, a gravitational anchor that will never fade. Galaxies are not isolated islands. They live in families, pairs, groups, and clusters. The Milky Way, for instance, belongs to the local group, a small gathering of more than 50 galaxies, including the Andromeda Galaxy and the Magellanic Clouds. These members are bound together by gravity, orbiting and interacting over cosmic time. Larger clusters, such as the Virgo cluster, contain thousands of galaxies, embedded in a vast cloud of hot gas that emits X-rays. Between the galaxies, dark matter weaves its web, holding the cluster together. On even larger scales, clusters themselves form superclusters, the grandest structures in the cosmos, stretching across hundreds of millions of light years. The universe, when seen from afar, resembles a cosmic foam, dense filaments of galaxies surrounding vast, empty voids. Within this immense tapestry, galaxies move like slow currents in a cosmic ocean. They are drawn toward regions of higher density, toward the nodes of the cosmic web. The patterns of motion trace invisible gravity wells, the fingerprints of dark matter and the relics of the Big Bang. And yet, despite all this motion, the universe feels still. If you could float between the galaxies, you would experience a silence so complete that it feels infinite. The light of distant galaxies would appear as faint smudges on a velvet background, their movement imperceptible to the human eye. But over billions of years, they drift, merge, and evolve, their shapes shifting like clouds across the sky of eternity. When two spiral galaxies collide, the result can be spectacular. Their stars pass through one another like ghosts, while the gas clouds compress and ignite in waves of star formation. The two systems twist and distort, forming tidal tails, long streams of stars flung into intergalactic space. Eventually, the two galaxies merge into one, often forming a new elliptical galaxy. The Milky Way itself will one day meet such a fate. In roughly 4 billion years, it will collide with the Andromeda Galaxy, its nearest large neighbor. As they approach, their shapes will warp and stretch. Stars will be thrown into long arcs, and new stars will be born in bursts of light. After another few billion years, the two galaxies will settle into a single, larger system, perhaps an enormous elliptical galaxy, glowing softly in the darkness. From our vantage point, this is a distant future, but in the life of the universe, it is simply another breath in the rhythm of creation. Even now, faint streams of stars in the outer halo of the Milky Way tell us that smaller galaxies have already merged with ours. These streams are the remnants of long-gone systems, their stars now part of our own. Every galaxy carries such scars, faint traces of its history written in the motion of its stars. In this way, galaxies are not static entities. They are dynamic, evolving structures, shaped by time, gravity, and chance. They grow, merge, fade, and renew themselves over cosmic cycles. Their light is both present and ancient, a message that has traveled across billions of years to reach us. To look at a galaxy is to look at time itself. The Andromeda Galaxy we see in the sky tonight appears as it was more than 2 million years ago. The faint smudges seen through powerful telescopes, the distant galaxies at the edge of the observable universe, show us how the cosmos looked billions of years in the past. Every photon is a time traveler, carrying with it the story of where it came from. And so, The universe becomes a museum of light, its exhibits arranged not by place, but by time. The deeper we look, the younger the galaxies appear. Some are still forming, glowing with the intense blue light of newborn stars. Others are already mature, settled, filled with older, cooler stars. Through this cosmic time machine, we can trace the life of galaxies, from the turbulent youth to the graceful old age. The study of galaxies is, in essence, the study of cosmic memory. Each one preserves the history of the universe in its stars, its structure, its motion. In their collective glow, we find the story of matter itself, how it gathered, ignited, and became light. And in that light, perhaps we find something more. A reminder that creation, in its grandest form, is never complete. It continues, quietly and endlessly, in the deep, slow rhythm of galaxies turning through time. In the beginning, galaxies were fragile things, small clouds of stars, dust, and gas, born amid the turbulence of the young universe. Over time, they grew and evolved, their shapes shifting as gravity guided their destinies. Galaxies, like living beings, experience birth, growth, transformation, and eventual quiet. The life of a galaxy begins with gas. Hydrogen, the simplest and most abundant element in the cosmos, collects within dark matter halos, cooling slowly across millions of years. When the gas becomes dense enough, it collapses under its own gravity, forming stars. The first generation of stars in a young galaxy are massive and bright. They burn fiercely, living fast and dying young, leaving behind clouds enriched with heavier elements. As these stars die in supernova explosions, they scatter carbon, oxygen, nitrogen, and iron, the raw ingredients for future stars and planets. Each cycle of birth and death enriches the galaxy, adding complexity to the cosmic mixture. Over billions of years, galaxies become laboratories of chemical evolution. They build themselves, layer by layer, through the lives of their stars. The stars themselves become the storytellers of the galaxy. Their light carries the imprint of their composition, their temperature, and their age. By studying that light, astronomers can read a galaxy's history as though it were written in starlight. Galaxies do not live in isolation. They interact constantly, drawn together by the invisible threads of gravity, orbiting one another, colliding, merging, and exchanging material. Through these encounters, galaxies grow larger, but also more diverse in form and behavior. When two galaxies approach each other, their immense gravitational fields begin to intertwine long before they touch. Their shapes distort, spiral arms stretch, streams of stars are drawn outward, and gas clouds are compressed into bright bursts of star formation. These interactions can last for hundreds of millions of years, unfolding in slow motion across cosmic time. Eventually, the two systems merge, becoming one. The result may be a new, larger galaxy, often elliptical in shape, formed from the blended stars of both parents. The new galaxy will contain traces of its past, streams of stars left behind like trails of cosmic memory, shells and arcs that whisper of an ancient collision. Some galaxies experience such mergers repeatedly. Over time, they grow into massive ellipticals, vast, smooth collections of old stars, no longer forming new ones. The collisions that create these giants also heat the gas, preventing it from cooling and forming stars. These galaxies glow softly with the light of old, red suns, drifting quietly through the cosmic web like embers cooling in the dark. In contrast, smaller galaxies continue to form new stars. They remain rich in gas and dust, their spiral arms alive with activity. The interplay between star formation and feedback, the energy released by supernovae and stellar winds, governs their evolution. Too much feedback, and the gas is blown away, quenching new stars. Too little, and the galaxy collapses inward, triggering violent bursts of formation that exhaust the available material. Thus, a galaxy must maintain a delicate balance. a rhythm between creation and restraint, between gravity and light. Over billions of years, this rhythm defines its character. Some galaxies sustain slow, steady star formation for eons. Others burn brightly for a time, then fade into stillness. The environment in which a galaxy lives also plays a role in its fate. Galaxies in dense clusters feel the pull of their neighbors. The hot gas that fills the space between them can strip away their outer layers, removing the fuel for new stars. These galaxies become quiescent, silent and red, their youth long gone. In contrast, galaxies in the quiet outskirts of space, in cosmic voids and filaments far from clusters, evolve more gently. They keep their gas longer, forming stars over extended timescales. The universe's environment shapes each galaxy differently, just as climate shapes life on a planet. At the heart of most large galaxies lies a hidden engine, a supermassive black hole. In the early universe, these black holes grew rapidly, fed by the inflow of gas and dust. As material fell toward them, it heated and emitted brilliant radiation, creating quasars, the most luminous objects in the cosmos. For a time, these quasars outshone entire galaxies, their light visible across billions of light years. They marked the universe's energetic youth, when matter and energy interacted in spectacular ways. Over time, as their fuel was consumed, most quasars faded, leaving behind quiet black holes, sleeping giants that remain to this day. Even in dormancy, these black holes shape their galaxies. Their gravitational pull stabilizes the surrounding stars, while occasional bursts of activity, when gas spirals inward again, can heat or expel material from the galaxy's core. This process regulates star formation, ensuring that galaxies neither burn out too quickly nor collapse under their own abundance. Astronomers call this balance feedback, a self-regulating mechanism that allows galaxies to evolve in harmony with their central black holes. It is as though the galaxy breathes, exhaling light and energy, then resting in silence. Over immense stretches of time, galaxies age. Their gas reserves dwindle. Their youngest, bluest stars die, leaving behind older, cooler stars that emit a gentler glow. Dust settles, and the arms of spirals begin to fade. The galaxy's light reddens, becoming softer, more diffuse. These aged galaxies drift through the universe like ancient cities, their lights still shining, but their activity long past. They remain stable for billions of years, slowly dimming as their stars burn their last fuel. Eventually, even those stars will fade, leaving only remnants, white dwarfs, neutron stars, and black holes, scattered across the galactic skeleton. But the story does not end there. Matter never truly disappears. Over unimaginable timescales, even in the quietest galaxies, gravity continues its work. Stars that drift too close to the central black hole are devoured, releasing brief flashes of light. Occasionally, galaxies encounter one another again, rekindling bursts of creation. In this way, the cosmic cycle continues, endless and self-renewing. The light from distant galaxies carries this story across billions of years. When we observe a faint, red-shifted smudge through a telescope, we are seeing it as it once was, perhaps when the universe was only a fraction of its current age. That light, stretched by the expansion of space, tells us how the galaxy lived, how its stars burned, and how its gas moved. Modern instruments, like the Hubble and James Webb Space Telescopes, allow us to look deeper into this cosmic past than ever before. They reveal galaxies forming just a few 100 million years after the Big Bang. Small, bright, irregular clusters of stars, the ancestors of today's majestic spirals and ellipticals. Through these observations, astronomers can reconstruct the universe's family tree. They can trace how small galaxies merged into larger ones, how star formation changed over time, and how the cosmic web evolved. Each new discovery refines our understanding of how galaxies became the complex systems we see today. And yet, even now, mysteries remain. We do not yet fully understand how the first supermassive black holes grew so quickly, or how dark matter shaped the earliest structures. We do not know precisely how the interplay of gravity, radiation, and feedback gives rise to the diversity of galactic forms. The universe keeps some of its secrets hidden, perhaps waiting for future generations to listen closely enough to hear them. In the meantime, we continue to watch, to trace the faint light across the deep sky, to decode the patterns written in it. Every observation brings us closer to understanding the cosmic story of structure and change. But galaxies are not merely objects to be studied. They are also mirrors. When we look at them, we see reflected the passage of time, the persistence of light, and the quiet endurance of creation itself. The Milky Way, for example, is not static. Its spiral arms are transient features, shaped by waves of density that move through its disk. Stars are born within those waves and drift outward as they age, giving the illusion of rotating arms. Meanwhile, smaller galaxies orbit us, the Sagittarius dwarf, the Magellanic Clouds, slowly being drawn in, their stars stripped and added to our own. Our galaxy is alive in motion. It breathes in time with the universe. The stars of the Milky Way orbit the galactic center once every 200 million years. Our Sun, and all the planets with it, have completed only about 20 of these orbits since their formation. The galaxy has changed since then. Stars born and dead, arms shifted, companions merged. And yet, the pattern remains, a slow, graceful dance held together by invisible threads of gravity. Across the night sky, every visible star belongs to our galaxy. The faint Milky Way band, stretching across the heavens, is our home seen from within. But beyond that ribbon of light, countless other galaxies gleam, each with its own stars, planets, and stories. Through telescopes, we can see thousands in a single small patch of sky. The Hubble Ultra Deep Field, for instance, reveals more than 10,000 galaxies in a region no larger than a grain of sand held at arm's length. Multiply that across the whole sky, and there are perhaps 2 trillion galaxies in the observable universe. Each one unique. Each one a universe of its own. The light from these galaxies travels immense distances, crossing expanding space for billions of years before reaching us. Some of it began its journey long before the Earth existed, before the Sun had formed, before even our galaxy had taken its present shape. To receive that light is to touch the deep past. And yet, that light continues onward. Even after it reaches us, it does not stop. It passes through, carrying its story to anyone who will listen across the future of time. In this way, galaxies are storytellers that never rest. Their language is light, their history written across the universe. As we drift in this sea of galaxies, we begin to sense the vastness not as something cold or distant, but as something deeply connected, a slow unfolding of creation, sustained by simple laws and endless time. We, too, are part of that unfolding. The atoms in our bodies, the calcium in our bones, the iron in our blood, were forged in long-dead stars within ancient galaxies. The carbon we breathe was born in the fusion hearts of suns that shone billions of years ago, in galaxies long vanished from view. We are, quite literally, the dust of galaxies, the recycled matter of cosmic evolution. To lie beneath the stars at night and gaze at the Milky Way is to feel that connection. The same forces that shaped those distant lights shaped us as well. The same gravity that holds galaxies together holds us to this planet. The same hydrogen that burns in distant suns fills our cells and our oceans. When we look outward, we are looking home. And when we close our eyes, we can almost hear it, the slow hum of creation, the deep silence between galaxies, the quiet pulse of time. Galaxies are not just collections of matter. They are the expression of the universe's own memory, a record of how chaos became order, how darkness gave rise to light, and how the cosmos continues to create itself. In their light, we see our own beginnings. In their fading, we glimpse our future. The life of a galaxy is long beyond comprehension, yet it follows patterns as natural as breathing. Stars form, shine, and die. Gas flows inward, outflows push it away. Gravity binds, expansion separates. All of it part of the same eternal cycle, the cosmos renewing itself, one quiet turn at a time. And so, when you look up at the night sky, know that you are looking at an unfolding story that has no true end, only transformation. Every galaxy is a moment in that story. Every star, a word. Every photon, a whisper across time. And we, here, on our small, luminous world, are listening. Imagine drifting farther and farther away from any one galaxy, until its spiral arms fade into a single point of light. Keep going still, past neighboring systems, beyond the small groups where galaxies gather like families. At last, patterns begin to appear, not of single lights, but of threads and knots, of luminous strands stretching across unimaginable distances. This is the large-scale structure of the universe, a web woven of galaxies. Each glowing thread is a filament, filled with clusters and superclusters of galaxies, stretching for hundreds of millions of light years. Between them lie vast, dark voids, enormous regions almost empty of matter, silent and cold. The contrast between light and emptiness defines the architecture of everything that exists. These filaments were born from the faint ripples of density that filled the early universe. Where matter was slightly denser, gravity drew it inward. Over billions of years, those regions condensed, forming the cosmic scaffolding that would host galaxies. Where the density was lower, matter flowed away, leaving behind the deep voids. Seen in 3 dimensions, the universe resembles a foam of light. Galaxies trace the thin walls, clusters shine at the intersections where filaments meet. In the spaces between, darkness reigns, immense stretches of near-nothingness, wider than imagination. Within the knots of this web lie galaxy clusters, the largest gravitationally bound systems known. A single cluster can contain thousands of galaxies, bound together by an envelope of dark matter and immersed in a cloud of extremely hot gas. That gas, invisible to ordinary sight, glows in X-rays. It is thin, far emptier than any vacuum we can create on Earth, yet its vast volume makes it one of the dominant forms of ordinary matter in the cosmos. This intracluster medium acts as both a cradle and a constraint. Galaxies moving through it feel its resistance, the gas stripped away by its pressure. Over time, this process quenches star formation, turning once blue spirals into quiet ellipticals. The center of a rich cluster is often home to a giant elliptical galaxy, a vast, luminous city of ancient stars. These central galaxies grow by consuming smaller neighbors, drawing them inward through a slow gravitational dance. Their cores may contain some of the most massive black holes ever found, engines that release tremendous energy as they feed, sending ripples of hot gas outward through the cluster. Clusters do not stand still. They orbit one another, merge, and form still greater assemblies called superclusters. The Virgo supercluster, for instance, contains our own local group of galaxies along with thousands of others. Yet even superclusters are not bound forever. On scales larger than about a few hundred million light years, the expansion of the universe overcomes gravity's pull. Beyond those scales, the cosmic web simply stretches, its filaments carried outward by the growth of space itself. The motion of galaxies through this web is subtle but inexorable. Each one responds to the combined gravity of all others nearby, flowing along invisible highways toward regions of greater density. The patterns of motion reveal the hidden mass that shapes them. When astronomers map the distribution of galaxies across the sky, they see the imprint of those primordial ripples that once stirred the infant universe. From these maps, a deep truth emerges: the universe is both simple and complex. Its large-scale structure can be described by a few basic parameters: the amount of dark matter, the density of ordinary matter, the rate of cosmic expansion. Yet the details, the filigree of individual galaxies and clusters, show infinite variation. In this grand network, every galaxy is a node in a vast conversation held by gravity. Their interactions send ripples through the web, subtle exchanges of energy that continue for billions of years. If one could watch this network evolve in accelerated time, it would resemble a living organism. Filaments would thicken and stretch, clusters would merge, voids would expand, and the entire pattern would shift like slow tides. What we see in telescopes is only a single frame of this endless motion. Our Milky Way and its companions belong to a filament on the edge of a great basin of attraction called the Laniakea supercluster, a region spanning more than 500 million light-years, encompassing hundreds of thousands of galaxies. The name means immense heaven, a fitting phrase for the territory our galaxy drifts within. All of these galaxies, including ours, are gradually moving toward a common center of gravity, a mysterious region astronomers call the Great Attractor. No single object resides there. Rather, it is a concentration of mass, the sum of many clusters and dark matter halos. Its pull subtly influences the motion of our entire local group, guiding us through space at hundreds of kilometers per second. Yet we do not feel this motion. To us, the stars seem still. The scale of the journey is too vast for human senses to perceive. Within clusters and filaments, galaxies sometimes form chains, compact groups bound together more tightly than the broader web. These groups are laboratories of interaction, where tidal forces sculpt galaxies into new shapes. Some galaxies are stretched into long arcs, others are stripped of their outer stars, leaving only their luminous cores. The remains drift through the cluster as faint streaks of light called intracluster stars, homeless suns wandering between worlds. When astronomers capture images of these clusters, they often find the background light distorted, arcs and rings curving around the cluster's mass. This is gravitational lensing, the bending of light by gravity itself. Massive clusters act like cosmic lenses, magnifying and warping the images of galaxies far beyond them. Through this natural phenomenon, we can glimpse the most distant galaxies ever observed, their light amplified by the invisible hand of gravity. Gravitational lensing also reveals the distribution of dark matter. The way light bends traces the unseen mass that fills the cluster. By mapping these distortions, astronomers can draw pictures of dark matter's presence, outlining the invisible framework that holds the universe together. In the heart of some clusters, collisions between massive galaxies create extraordinary phenomena. The hot gas between them may generate shock waves that ripple for millions of light years. Streams of dark matter pass through one another unhindered, while the visible matter lags behind. Observations of such events, like the famous bullet cluster, provide some of the clearest evidence that dark matter truly exists, behaving differently from ordinary gas and stars. Through these cosmic laboratories, we learn that matter interacts in multiple ways, some visible, some hidden, yet all guided by the same universal laws. As we step back still farther, the pattern continues to repeat. Filaments connect clusters. Clusters connect to superclusters. Beyond them stretch even larger structures, faint and delicate. The cosmic web spans the entire observable universe, roughly 93 billion light-years across, though expanding still. And in all that space, the light from every galaxy contributes to a faint glow, the cosmic infrared and optical backgrounds, the collective whisper of uncounted suns. Between these threads, the voids expand, regions so empty that a single atom may occupy a cubic meter of space. Yet even these voids are not truly vacant. Dark matter permeates them, and the expansion of the universe continues to sculpt their boundaries. The scale is beyond imagining, yet the principles remain simple. Gravity pulls, expansion stretches, and light travels. Out of these three acts, the universe writes its story. When you look at images of the cosmic web, perhaps generated by supercomputer simulations, you see a structure that resembles neurons in a brain or filaments in living tissue. Some scientists and philosophers find comfort in that resemblance, as though the universe itself might be thought of as a kind of vast, self-organizing intelligence. Others see it simply as a natural outcome of physics. Either way, it stirs a quiet awe. For in this pattern, we see unity, the same laws shaping everything, from the dance of galaxies to the orbit of a single moon. And though the distances are incomprehensible, there is peace in knowing that it all follows an elegant order. The galaxies move not in chaos but in harmony, each following the gentle curve of space-time itself. The cosmic web is not static. Over billions of years, its filaments grow thinner as the universe expands. Clusters may remain bound, but the spaces between them widen. One day, far in the future, galaxies outside our local supercluster will drift beyond our horizon, their light stretched into darkness by the accelerating expansion. Future observers will see only the nearby galaxies, the rest lost to the deep night. But tonight, while we can still see them, we may rest in the quiet realization that we live inside this luminous network. One node among trillions, one brief moment in the long unfolding of cosmic time. If you could listen to it, you might hear nothing at all. No sound crosses those distances, no air to carry a wave. Yet the silence is not empty. It is full of motion, of faint radiation, of the slow dialogue between gravity and expansion. The cosmic web hums in its own way, a vibration written in the background of existence. In that hum lies everything: the origin of galaxies, the flow of matter, the future of light. And as you drift in thought, imagining the filaments stretching into infinity, perhaps you can feel the serenity of it, a structure vast and delicate, ancient and still alive. The universe breathes, and we breathe with it. When we look at the universe, what we see, the stars, the glowing gas, the spirals of galaxies, is only a fraction of what truly exists. The rest, though hidden from sight, reveals itself through gravity, through the gentle bending of light, through the motions of galaxies across the sky. Roughly 5% of the cosmos is made of ordinary matter, the atoms that form everything we know. The remaining 95% lies beyond the reach of our senses. Most of it, about 27%, is dark matter, invisible, silent, but essential. The rest, nearly 70%, is something stranger still: dark energy, the force that drives the accelerated expansion of space itself. Dark matter is the invisible framework on which galaxies are built. It does not emit or absorb light, yet its gravity sculpts the universe. Long before stars and galaxies existed, dark matter was already forming halos, immense, spherical envelopes of mass that would later attract ordinary matter into their centers. These halos acted as cosmic seeds, gathering gas that cooled, condensed, and ignited into stars. Without dark matter, galaxies as we know them could not have formed. Ordinary matter alone would have taken too long to coalesce under gravity's pull. Radiation pressure and the rapid expansion of the early universe would have scattered it too widely. But the dark matter, unaffected by light, clumped together early, providing the gravitational wells in which galaxies could take shape. When we simulate the universe on supercomputers, dark matter becomes the invisible web that threads through space. Galaxies appear where its filaments intersect, like dew forming on the crossing strands of a spider's web. In this way, dark matter determines the cosmic geography, deciding where stars will shine and where the night will remain empty. We know it must exist because of its gravitational fingerprints. The way galaxies rotate is one clue. The stars in their outer regions move too quickly to be held by visible matter alone. Without dark matter's extra mass, those galaxies would fly apart. The bending of light around clusters, the behavior of hot gas, the distribution of cosmic microwave background radiation, all point to the same hidden presence. Though we have never seen dark matter directly, we have learned much about its behavior. It seems to be cold, meaning that its particles move slowly compared to the speed of light, allowing it to clump on galactic scales. It interacts with ordinary matter only through gravity, not through electromagnetism, which is why it neither shines nor scatters light. Scientists have proposed many candidates for what dark matter could be, from weakly interacting massive particles, or WIMPs, to axions, sterile neutrinos, or even more exotic possibilities. Detectors deep underground, shielded from cosmic rays, wait silently for the faintest sign of interaction. So far, none have spoken. Yet the search continues, because understanding dark matter is to understand the universe's skeleton, its enduring shape. Dark matter halos surround every galaxy like invisible cocoons. The Milky Way, too, resides within such a halo that extends far beyond its visible disk. Stars, planets, and even the vast clouds of gas we can see form only the luminous core of this larger, unseen structure. But dark matter, powerful though it is, does not act alone. If dark matter governs the structure of the cosmos, dark energy governs its destiny. In the late 1990s, astronomers studying distant supernovae discovered something unexpected. Instead of slowing down under gravity, the expansion of the universe was speeding up. Space itself was stretching faster and faster over time. The simplest explanation was the existence of a new form of energy, uniform, invisible, and woven into the very fabric of space-time. Dark energy, whatever it is, acts as a kind of cosmic pressure, pushing galaxies apart. It is not a force that acts on matter directly. Rather, it affects the geometry of the universe itself, causing the metric of space to expand. As space expands, the distance between galaxies grows. Light traveling across the cosmos is stretched into longer wavelengths, making distant galaxies appear redder and dimmer. Over billions of years, this expansion reshapes the universe, diluting matter and isolating galaxies within their own local clusters. In the far future, dark energy will continue its work, slowly erasing the visible connections between galaxies. The great filaments of the cosmic web will thin, and only the densest clusters will remain gravitationally bound. Beyond them, everything else will recede beyond the cosmic horizon, disappearing from view forever. For now, we live in a transitional era, one in which the forces of gravity and expansion are balanced in a delicate tension. Galaxies still form, still merge, still shine, but the signs of cosmic aging are already visible. Star formation rates have declined over the last billions of years, and many galaxies have grown quiet, their gas spent or stripped away. The universe is still vibrant, but its youth has passed. Dark energy's nature remains mysterious. Some scientists describe it as a cosmological constant, a property of empty space itself. Others imagine it as a dynamic field, evolving slowly over time, or as a sign that our understanding of gravity is incomplete. Observations of distant galaxies, supernovae, and the cosmic microwave background continue to refine our measurements, but the true identity of dark energy eludes us. Yet, in its mystery, there is a kind of beauty. It reminds us that even after centuries of study, the universe keeps its deepest secrets close. The interplay of dark matter and dark energy defines the shape and fate of everything we see. Dark matter draws structures together. Dark energy pulls them apart. The history of the cosmos is a story written between those two opposing tendencies. Early on, dark matter dominated. It gathered gas into stars and galaxies, forming the luminous scaffolding we observe. Later, as the universe expanded and matter grew more dilute, dark energy began to dominate, accelerating the expansion and driving galaxies apart. This cosmic shift marked the beginning of a new era, one in which creation gave way to dispersion, and the great clusters began to drift toward solitude. Still, even as the distances widen, the forces of gravity preserve islands of stability. Within each cluster, galaxies remain bound, orbiting in slow ballet. Stars continue to burn, to collapse, to explode, enriching the surrounding gas with heavy elements. Planets still circle their suns, and in some quiet corners, life may arise, contemplate the sky, and wonder. On those worlds, perhaps beings not unlike ourselves might look outward and see the same faint glow of distant galaxies. The universe expands, but its essence does not change. Energy becomes matter, matter becomes energy, stars form and fade, and the fabric of space stretches to accommodate it all. Nothing is lost, it only transforms. In that realization lies a kind of calm. The cycles of creation and destruction, the long evolution of galaxies, the ceaseless drift of cosmic expansion. They are not random acts, but expressions of balance. Even entropy, the slow diffusion of energy, is simply another way for the universe to maintain its rhythm. The more one learns of this, the quieter the mind becomes. There is no need to chase meaning beyond what is already here. Existence itself is the meaning, the interplay of order and chaos, of brightness and shadow, of birth and return. The galaxies show us this truth wordlessly, in their steady turning. Far away, in the faint outskirts of space, the first galaxies still shine from the earliest times. Their light has traveled for more than 13 billion years to reach us, yet it still carries the signature of its beginning. Those ancient photons slip silently through the dark, brushing past planets, dust, and the thin gas between stars, until they reach the mirror of a telescope or the lens of an eye. And there, after their endless flight, they become vision. For a moment, you can imagine all those lights together, the combined glow of every star, every world, every fragment of matter that has ever existed. It forms a single, soft radiance that fills the mind like dawn. The boundaries of galaxies fade, their shapes blur into one another. The cosmos becomes not a collection of separate things, but a single field of luminous possibility. As you float in that thought, the distances lose their sharpness. The difference between near and far, small and large, present and past, begins to dissolve. There is only light, spreading, cooling, continuing. Somewhere deep inside this vastness, a single heartbeat continues its quiet rhythm. It, too, belongs here. It, too, is part of the pattern. The body that carries it was made from cosmic dust. The warmth that sustains it was born in a star. You are not apart from this. You are this. And in that awareness, the universe feels suddenly intimate. Not an external expanse to be measured, but a home to rest within. The galaxies drift around you like gentle thoughts. The dark between them is not emptiness, but rest, the quiet in which everything finds balance. Let yourself drift with them, slow and unhurried, through the unending night. You drift farther now, and the light thins. Each galaxy becomes a glimmer, then a thread, then only a whisper of brightness folded into darkness. Yet even here, where vision falters, there is a sense of fullness, as though the dark itself is alive with unseen motion. The mind can wander here without fear. There are no boundaries to meet, no edges to press against. Space curves gently in every direction, carrying you like a tide that never breaks. Every few billion years, new galaxies will form, and others will fade, but the ocean remains. If you could watch time from this distance, it would look like breathing. Clusters condense, filaments stretch, voids expand. The whole universe inhales and exhales in slow, patient cycles. And within that vast respiration, life continues to appear. Small sparks of awareness lighting up across the darkness, wondering who they are, wondering where they came from. All the while, the universe keeps offering the same silent answer: you are already home. It says it in the curve of spiral arms, in the shimmer of a nebula, in the rhythm of a beating heart. The laws that shape galaxies also shape thought. The symmetry that builds stars also builds the delicate structure of memory. When you close your eyes, that pattern doesn't disappear. It simply turns inward. The mind becomes its own galaxy. Thoughts orbiting around moments of brightness. Old memories collapsing into new ideas. Imagination expanding like a spiral of stars. Consciousness itself feels like a small echo of cosmic structure. Luminous, infinite in potential, quietly self-aware. Even sleep follows this pattern. Each night, awareness dissolves into darkness, only to be reborn again at dawn. In that cycle, you mirror the stars, burning for a while, then resting, then returning. Every breath, every pause between thoughts, is a small act of creation and release. It's easy to forget this, to believe that the cosmos is something far away, unreachable. But in truth, the same physics that govern the galaxies unfold within you at every instant. Electrons orbit atomic nuclei just as planets orbit stars. Fields of energy weave through your cells, responding to forces older than time. When you breathe out, the molecules drift upward, perhaps one day to rise through the atmosphere and return to the interstellar medium. In 1,000,000 years, they might be drawn into a new cloud of gas, collapsing into a newborn star. In that star, heavier elements will form, and someday those elements will gather into another world, perhaps another living being, who will look up and wonder, just as you do now. So, in this quiet moment, as you imagine galaxies turning, you are also watching your own future and your own past. The cosmos is not a story that happened long ago. It is a story still being told, and you are one of its sentences. Brief, beautiful, necessary. Look again, in your mind, at that endless field of galaxies. Each one is a thought, each one a possibility. Between them stretches the gentle dark, the space that allows each to shine. Without the dark, the light would have nowhere to live. Without stillness, motion would lose its meaning. The universe holds both, perfectly balanced, perfectly whole. And so do you. Inside every pause, there is the potential for something new. Inside every moment of silence, there is the whisper of creation. The voice of the narrator slows, softer now, like starlight fading at dawn. The pace of thought lengthens. You can feel the vastness of time not as a measure, but as a calm. All that exists, all that ever will exist, is here, expanding quietly around you, through you, within you. Imagine floating past the last faint galaxies, into the thin light at the edge of what can be seen. Beyond this point, there is only potential, regions where matter has not yet gathered, where time has hardly begun. The cosmic microwave background still glows faintly, a memory of origin, a whisper from the first moment of everything. It is 725 Kelvin now, cooling ever so slightly as the universe grows. That glow, stretched thin across eternity, is the oldest light you will ever meet. It touches you even now, invisibly. Every second, photons from that ancient fire pass through your body, through the walls, through the earth itself. They have traveled for nearly 14 billion years to find you, not with purpose, but with inevitability. You are the destination only because you are here, at this precise intersection of space and time. And that realization brings a stillness deeper than silence. There is nothing more to reach for. There is only to rest in what is, the quiet grandeur of existence, the simple fact of being part of it all. The galaxies fade into mist. The mist becomes colorless, then transparent, until even the thought of light begins to dissolve. You are left with the hum of space itself, steady, gentle, infinite. Perhaps this is what the universe feels like from the inside. Not a sound, not a sight, but a calm awareness that never ends. Let it carry you now. Let the stars and the distances blur together until all that remains is the warmth of your own presence, suspended in the same quiet that holds everything else. The boundaries between body and cosmos soften. The breath slows. The heartbeat becomes indistinguishable from the low rhythm of the galaxies. There is no need to understand more. There is no need to move. Only to float, to rest, to listen as the universe continues its patient expansion, carrying every thought, every dream, every spark of life along with it. In this stillness, you are whole. You are part of the same unfolding that gave birth to stars, to worlds, to wonder itself. And as the last trace of light drifts outward, the narration fades, not to an ending, but to the endless horizon, where all galaxies glide together in the quiet motion of forever.